or at the bottom. So that can actually be pretty useful. As an example, if you want facing shape particles pointing towards the camera, flying through space, and you want the leading edge of the particle to be, let's say, a little ball of flame with some flame coming off it, then you probably want the ball of flame to be at, say, the bottom or the top edge of the particle. And then that would be the pivot point. And then if the ball of flame were to change direction, it would obviously pivot from that point, and it wouldn't work very well if the pivot was in the center. So it depends on what you're trying to do with your facing shapes, but you've got some, you know, flexibility there. You've got an option of bottom, center, and top. So we'll just put it back to the default. The second thing, obviously, is the actual aspect ratio of the facing shapes. You can see that the default aspect ratio is 1. This is a width to height ratio, and if we don't want that, we can actually increase that value. That will actually make the width wider, decrease it, and it'll make the facing shapes taller. So you can basically change that ratio to suit your image. If your image has a different aspect ratio from 1, then you can work out the aspect ratio using a little bit of maths, pop it in there, and then you know that your facing shapes match the aspect ratio of your images that you're going to project onto those facing shapes. So that's a pretty useful option. Just put that back to 1. I mean, in our case, the this image here is, as far as I remember, it's something like 640 480 or 800 600. So our, you know, aspect ratio here of 1 is wrong. It should probably be something like that, you know, so they're a little bit wider than they are tall. Then the next option is the orientation of the facing shapes beyond that of just facing towards the camera. Now, the standard thing to happen with a facing shape, and for this I'll actually turn on mapping again because it'll give us a better idea of what's going on with our particles. If you think about these particles, they have a horizontal line running through them. You know, this is, you know, this is top, this is bottom, left, right, and each of these particles you can see is facing upwards. But what is it that actually makes it face upwards? Well, rather, when I say by facing upwards, I mean the top edge of the particle is facing upwards in the scene. Well, each particle is actually aligning itself towards the horizon. It's not based on the orientation of the source object, so I can rotate this, and you can see although the particles are actually rotating around, the actual top axis of them is always pointing upwards. And that's because they're all aligning to the horizon, which is the first option in the orientation flyout. The second option, if we have a look at that, is align to speed follow. That actually only makes any sense if you have any speed on the particles. As it turns out, we do. We've got some speed here, so they're actually moving up slowly. And you can see now that rather than this horizontal axis being aligned to the horizon, you can see it's now based on the speed of the particle. So it's actually aligning the horizontal axis with the direction of travel. So you can see all the particles are facing up this way. Now, as I said in the little example I gave earlier, with the, you know, tiny little fireballs with little streams of fire coming out from behind them, this is probably the option that you'd want to use. You know, as the particles fly around, you really want the facing shapes to be aligned with the speed. So as the particles change shape, the actual orientation of the particle changes shape to keep that matched up. So that's what you have with the line speed follow. You have a random option, which is pretty obvious. You know, at creation point, it just assigns a random rotation, or rather I should say random orientation, to each one of the facing shapes. And the last option doesn't really make any sense until you actually turn on, if you actually add a spin operator to the particle flow. So you can see I've actually got one here. If I go and turn that on, go back to shape facing, we'll go to align to horizon, and you'll see what actually happens here. You can see the particles are created. As they're created, it tries to spin them, but you can see because it's aligning it to the horizon, it locks it. So you can see they all pop, but apart from that, there's no actual spinning going on. So to allow spinning, you actually have to go down to the option which says allow spinning. It's pretty obvious really, isn't it? We'll turn on allow spinning, and now the particles are allowed to actually spin on their axis, wherever that may be. So you can see there they go, they're all spinning around. If I change the pivot point, you can see now they're all spinning around the pivot. But now obviously the pivot's at the top, so you get a completely different kind of motion. So there you go, that's quite interesting what you can actually do with that there. So that's it really for the shape facing object. You've got three main areas you've got to think of. What is the particle facing towards? You assign that using this button. What is the size of the particle? And you know, you can base that on three different options, as I said: world space, local space, or screen space. Where's the pivot? What's the width height ratio of the particle, the facing particle? What's it aligned to? Is it aligned to the horizon? Is it aligned to the speed of the particle? Is it a random alignment? And if you've got any sort of spinning assigned, do you allow that to happen? Okay, so that's it for the shape facing operator. Let's move on and have a look at the shape instance operator.